interference fit. We completed clearance fit. Similarly, next interference fit. So interference fit is the fit formed by the external force. External force. So it is very tight fit. So you need external force to form a fit between shaft and hole. So because there is no gap between them, so you need to give extra force to insert a shaft into the hole. Necessary condition. So what is the necessary condition to satisfy the interference fit is as we know that in clearance fit the lower limit of hole is greater than the higher limit of shaft. Similarly, in interference fit the higher limit of shaft, lower limit of shaft should be greater than the upper limit of hole, reverse of the clearance fit. So necessary condition is lower limit of shaft greater than the upper limit of hole. This is a necessary condition. So for example, if you draw the diagram, it's opposite to the clearance fit. If you draw the diagram, tolerance of shaft and tolerance of hole. So this is shaft, this is hole. If you draw the line diagram separately, so this is hole, so you need to insert a shaft whose size is bigger than the hole into the smaller hole. So inserting a shaft of size bigger than the hole. So if you want to insert a big shaft into the small hole, you need external force. That's why it is called interference fit. So if you look at the diagram here, so lower limit it is upper limit of shaft and lower limit of shaft, upper limit of hole, lower limit of hole. This is baseline. So it is satisfying our necessary condition as lower limit of shaft is greater than the upper limit of hole. Then the fit formed is called interference fit. External force is required for forming this interference fit. Similar to the clearance, maximum clearance, minimum clearance, here we have maximum interference and minimum interference. maximum interference and minimum interference. So maximum interference is defined as the difference between the lower limit of hole to the upper limit of shaft. Difference between upper limit of shaft minus lower limit of hole. Similarly, minimum interference calculation is same as the clearance, here interference. Minimum interference is lower limit of shaft minus upper limit of hole. Lower limit of shaft minus upper limit of hole. This is the minimum interference. Similarly, you can deviation, upper deviation of shaft, lower deviation of shaft for hole, upper deviation of hole and lower deviation of hole. So in this diagram, the lower limit of hole is same as the basic size, so minimum deviation is 0, lower deviation also 0. It's called standard deviation or fundamental deviation for hole is 0. This one is called lower deviation of or deviation of shaft. So if you add this to tolerance, this is tolerance of shaft. So the shaft dimension can vary between upper and lower limit, that is why it is called tolerance. This is tolerance of hole. So tolerance of hole. Tolerance of shaft and tolerance of hole. So if you know this, then you can solve the problems in this. All these problems are simple to solve. Tolerance of hole and tolerance of shaft. This is about interference fit. Examples of interference fit is force fit, tight fit, shrink fit, etc. So if you read the names, force fit, so you need external force. Tight fit, the name itself says that it is tight. Shrink fit, you have to apply external force. So these are application is for power transmissions. For power transmission we use interference fit. For power transmission interference fit is used. Next one is transition fit. So transition fit is it may be either clearance fit or interference fit, depending upon the dimensions which they have mentioned. It can be either of those. The necessary condition for transition fit is transition fit. So we have observed that in clearance fit there is a lot of gap between the shaft and hole. In interference fit there is no gap and it is very tight. So here similarly in transition fit, necessary condition is the upper limit or lower limit. Suppose for example take higher limit or upper limit of one part, one part means either hole or shaft, lies between upper and lower limit of other part. Lower limit of other part. Vice versa. So one part or lower limit lies between upper and lower limit of other part. So in a simple case, suppose this is hole, and here it is shaft. So hole upper limit lies between upper and lower limit of shaft. Similarly, shaft lower limit lies between upper and lower limit of hole. You can take anything, shaft or hole. Shaft, hole. So this can be, based upon the dimensions, this can be interference fit or clearance fit or so anything. Interference or transition is both of them. So this one is upper limit of hole, this one is lower limit of hole, this one is upper limit of shaft, lower limit of shaft. As we observe that upper limit of it is satisfying the necessary condition, so whenever the lower limit of shaft is higher than the dimension of the hole, upper limit of hole, then it is called interference fit. Or whenever upper limit of shaft is less than the lower limit of hole, then that is called clearance fit. So that's why it is in the middle of that one. It can be either in clearance fit or transition fit. Simple example I will take and then I explain you. Here 0.025, here 0.075, this is 0.05. For example, baseline is 50. So a shaft I will show you when interference fit form. So first, clearance fit. Clearance fit is formed. Suppose a shaft of dimension 50.05. I am taking the higher dimension. This is the shaft. So H 50.05. And hole is small h. Hole I can take it is 50.025, because hole dimension, as we know that shaft dimension varies from, so suppose for example I will write shaft dimension 50 is varying from 0.00 to 0.05. You can, it may be the manufacturing component may be either it in between the 50 plus 50 to 50.005. The range of the component, this means the range of the manufacturing component varies from 50 to 50.05. So what I have taken is, I have taken the component of size 50.05, and in from shaft I have taken 50.025. So shaft size is less than the hole size, so it forms clearance fit. Shaft size is less than the hole size, so it forms clearance fit. Next is interference fit example. So from the same lot I have collected two components, again one shaft and one hole, whose dimensions can form interference fit. So shaft I have taken, oh 1 second, sorry, this one is hole. This one is hole and this one is shaft. So hole size has to be, shaft size has to be less than the hole size, so it forms clearance fit, right? So here interference fit, shaft size has to be bigger, so shaft I am taking maximum one, 50.075, and hole I will take minimum one, small letter shaft. Hole capital letter, it has to be smaller, so 50.00 I will take lower limit. So as per our necessary condition, the shaft size is bigger than hole size, so it forms interference fit. So there may be thousands of shafts and for example, if I manufacture 1000 shafts which are ranging from 50.025 to 50.075, and there are 1000 holes which are values ranges diameter range from 50 mm to 50.05 mm. So from that lot I have selected two examples which can form both clearance and interference fit. So depending upon the problem, he will ask minimum clearance or minimum interference, maximum clearance and maximum interference. Okay. So that's about transition fit. This also used for power transmission, and especially their examples are push fit, wringing fit, zero interference. It is special fit where zero interference and zero clearance. So both are zero, that means shaft size is same as hole size. So that is fit is called transition fit, wringing fit. So this is about and this one, and here also we use for power transmission, and key is used for large power keyway or key is used for large power transmissions to connect two shafts, or key is used connect shaft and hole, also key is used. That's about transition fit. So we have completed clearance fit and interference fit, transition fit, which in a simple manner we will do one problem in gate question. Question number 6 in academy material. So gate 2005 1 mark question. In order to have interference fit, it is essential that the lower limit of shaft should be, for interference fit necessary condition is what? So interference fit, in interference fit, lower limit of shaft greater than upper limit of hole. So if you know this, just imagine, hole shaft size has to be bigger than the hole size. That is called interference fit. So answer is A. Next, there is another problem, 2 marks question in gate 2000. Question number 15. ME 2000, 2 marks question. So the problem he has given is a fit is specified as 25 H8 E8. The tolerance values for nominal diameter of 25 mm in IT8 is 33 microns. So before going to this problem, we need to discuss about what is IT8, IT7, all these tolerance grades. So we will do this problem maybe after completion of this.